Well, we've talked about direct variation and we've talked about inverse variation. Sometimes, though, we need to talk about variation when we have more than one thing going on at a time, and this is very often the case in the real world. So we have two different other ways of putting this. We have something called combined variation, and combined variation involves combinations of different relationships between variables, and they can be direct or inverse. Now, we also have something called joint variation, which is related, and it involves the product of two or more quantities. But let's go with one that's a combined variation. And here's an example. The current I in a direct current or DC circuit varies directly as the voltage and inversely as the resistance. All right. If the current is 28 amps when the voltage is 140 volts in a DC circuit with a resistance of 5 ohms, find the current when the voltage is 170 volts and the resistance is 8 ohms. All right, so we have a circuit, and then basically the way we think about a circuit, really basic one is this: there's some total amount of resistance to the flow of electrons in the wires. So right here, let's talk about this one. If it's current, I, we'll call it I is current. I varies directly as voltage, right? And, right, so we have another thing going on, and inversely as resistance. Then what do? Well, we know that the direct variation one, right, direct is the one that goes like this. It says y equals k times x is our model. And if it's inverse, we know that this is the relationship that goes y equals k over x. So what if it's both? Well, in this case, then, we're going to say that I, as our model, is equal to some constant. And it varies directly as voltage, V, and inversely as R. So we're going to write it as K times V divided by R. And we make that into one single quantity. All right, so that's useful to us because we're going to say we know that we have a current of 28 amps when we have a voltage of 140 volts and a resistance of 5 ohms. All right. Well, how do we deal with that one? Well, we can multiply both sides by 5 if we care to. All right. So take 5 times everything on the left. Take 5 times everything on the right. Of course, that cancels out the 5s over here. And we take 5 times 28. Well, 5 times 8 is 40. Right? Carry the 4. 5 times 2 is 10 plus 1. That's plus 4. That's 14. Oh, this is an easy one, right? The k times 140, and so dividing both sides by 140 makes it a very easy constant of proportion, which is to say our constant of proportion is equal to 1. So in reality, our variation equation looks like I equals 1 times V divided by R. So what is our current? Well, our current then in a circuit that has 170 volts times 1 divided by 8 ohms is going to be, well, let's see, 8 into 170. Well, this is where I need to do a little bit of division. I'll do it off to the side right here. 8 into 170 looks kind of like this. 8 goes into 17 twice, which we know gives us 16. So we would subtract away and we get 1, a 0. 8 goes into 10 once. It looks like we're going to have more digits, so I'm going to put my decimal here now. Subtract away 8, giving me 2. Bring down the 0 right here. 8 goes into 20 twice. giving us 2 times 8, 16. We subtract that away. Looks like we're going to have one more 0 here. 20 minus 16 is 4, so I'm going to bring down that last 0. And 8 goes into 40 exactly 5 times, and that subtracts out, gives us a remainder of 0. So it looks as though our current, I, will be 21.25. And so we would say the current in this particular circuit will equal 21.25 amps. That's the answer we were looking for, and so we're done. Let me rewrite that here. That looks a little weird. Leaky pen again. 21.25 amps. Okay, good to go.